Thank you all for joining me today. Our session today is titled Using JupyterHub and Coder as a User. This is one of two sessions today that will be back to back. The second one is basic Docker and Kubernetes. As you can see here, you can see the session table. So last week we had two sessions, which are Intro to NRP, that gave you an overview what NRP's mission is and what its capabilities are and how to gain access in general. The second talk was the portal, which navigates through NRP's website and user portal and how admins can add users and delegate access and provision namespaces and groups and scope users and promote, demote, and so on. Now, in our sessions here, by the end of these two sessions, hopefully, everyone watching these will be able to use NRP and Nautilus resources in an effective manner. And next week we have the intermediate Kubernetes session. Whatever we don't cover today, we'll go over next week. And then the second session next week is agentic tools and coding with AI on LLMs. Hopefully that would be a fun session to follow along with. And the week after that, it's September 16th is intermediate and agentic. September 30th is deploying JupyterHub and Coder. September 23rd is deploying JupyterHub and Coder. The difference there is deploying your own instances that you can customize. September 30th is the advanced sessions, so for advanced use cases. And here we always appreciate feedback. If you have anything that is more of an advanced or edge use case, we're always more than happy to include it in the advanced sessions. And of course, the sessions are back to back. They're 10 a.m. Pacific for those of you joining from Pacific time, which means 12 p.m. Central if you're joining Central, or 11 a.m. Mountain, and 1 p.m. Eastern if you're in the Eastern time zone. That's the first session. The second session is right after it. So each session is an hour long and they're back to back. The one on September 23rd, deploying JupyterHub and Coder, which is more of an advanced use case. It's scheduled for 1 hour. Of course, we'll be available for the next hour to answer as many questions as you can and cover over whatever you want. Please always feel free to ask as many questions and Q&As as you can. And on top of our training, we always host bi-weekly office hours as well. So users can go jump on a Zoom call, ask questions, if they have any issues they want. That is on top of the normal user support. And of course, office hours, as of time of making this video, they're on a bi-weekly basis. So every other Monday, there's office hours, and the timings are always announced via Matrix in the NRP news channel. And just because we're still getting questions about recording, just to make sure everybody's up to date with the recordings. As soon as we get our hands on the recordings, we'll post them to the training page, which you can see the link down here. So nrp.ai/training. You'll be able to see the recordings for the past sessions and the future sessions. That is as soon as we are able to get the recordings from Zoom. So right now, as of right now live, the videos are still not online, but as soon as we have our hands on them, we'll upload them instantly. And will there be an office hours section where we can share our screen to our problems? Someone here is listing a problem they're having with Conda environments. Of course, you're all during office hours, you're always more than welcome to come into office hours, explain your problems, and we'll be more than happy to help you out. Of course, Matrix as well. We're always happy to support you via Matrix. And this Monday we had office hours. That means not next Monday, but the Monday after that we'll also have office hours as well. And like I mentioned, they're always posted on Matrix. So always please make sure you're always available on Matrix. And for this session, what we're going to be talking about here is using JupyterHub and Coder. And first of all, just to reiterate, please, everyone who is watching this live, please make sure you're part of a namespace or a group so that you can follow the session and follow the tutorial live. And next session, the one after this, today we'll be using Kubernetes. So a few notes about JupyterHub and Coder. And so NRP itself, the National Research Platform, it's one Kubernetes cluster. So, and the cluster itself is called Nautilus. So when we say NRP and Nautilus, we're mentioning a Kubernetes cluster. And NRP hosts instances of both JupyterHub and Coder in Kubernetes. So both of them are actually running in Kubernetes, on Kubernetes, in their own namespaces. And just like how we run them in namespaces, users and namespace admins can run them as well, since they're easily deployable. And that's what the session on the deploying your own JupyterHub and Coder is about. You can deploy them in your own namespaces, customized, either bring your own domain name and expose them via domain name, or you can use a domain name that is something .nrp-nautilus.io. And for today's session, we're going to be showing you our NRP managed JupyterHub encoder. Now, just an important notice is that as of the time of making this training and presenting this training, this information is up to date. It's current with the NRP documentation. But please, since we want this training to always be relevant, please make sure that if you're not following this live, that you resort to NRP's official documentation as your number one source of information. The documentation we have is more of a live documentation where whenever we change something, whenever we implement new features, it's always documented, and it's not just blocks of text. If you follow our documentation, we have step-by-step examples that you can follow along. And just before we go carry on, just to make sure, so we have a few Q&A. So before we get started with the hands-on section, I'll make sure to add everybody who's on the call to a temporary namespace, but just make sure that this was covered in last week's session. To be part of a namespace, you have to be a PI or a part of a research group or campus IT, or in general, students themselves can't create namespaces. They're more added to namespaces, and then namespace admins, with a role typically reserved for PIs, promote users to admins if they wish. So for folks on the call, I'll add you a temporary namespace so you can follow along with the tutorial. But please, after the call, please sync up with me. If you're a PI, we can uh, we can add you through we can add you and create a namespace for you. If you're a student, you'll be able to contact your PI and they'll add you. They'll join NRP. They'll be a namespace admin. They'll be able to add you to namespaces and promote you if they wish so. Uh, as of the folks sending in Q&A, please, like, don't worry. Everything we will set you up with access before we hit the hands-on part. Just for now, let me just to get you through the section where we explain JupyterHub and Coder. Then once we explain what is offered there, we'll go to the hands-on section where we use them together, and then we can add you there. And I see someone raising their hand. Let me just you can unmute Javier.
Yeah, I'm just asking because I have access to NRP through Delta, but when I log in for this, I can't find a namespace associated with that. And I was wondering if you could help me with that.
Yeah, so just to make sure, when you say you have access through Delta, do you have a namespace that you're a part of?
I believe so. That's the part that's a little confusing to me.
So so if you're part of a current namespace, you should be able to see it on this link here. So nrp.ai/namespaces. If you're not seeing any namespaces there, that means you're not currently part of a namespace. And of course, we can triage that together off the call. But for now, if I'll add you to a temporary namespace to sort of go through the tutorial, and I'll happy to sync up and resolve the issues permanently as well.
Yeah, sounds good. I'll check it out on my end, but thank you.
Of course, you're welcome. And all right, so NRP's Jupyter Hub. And before we get in, just want to reiterate that everybody will make sure you're part of a namespace so you can follow along with everything. We'll add you. Just please in Q&A, everyone who's asking for access, just please sign in to nrp.ai. You have to sign in at least once to be sort of registered, sort of in the books, so we can add you. So please go to nrp.ai and click on the corner and sign in. And please send me your emails and Q&A, and I'll make sure to add you to a namespace that you can follow along with. For now, just to explain NRP's Jupyter Hub. So NRP has two Jupyter Hub instances, which are Jupyter Hub-West and Jupyter Hub-East, both of them .nrp-nautilus.io. And those are managed by us, the admin team. And of course, login to them is through CI logon, through an authentication platform that we use that is called Authentic. Uh, if you're part of a namespace or a group, you're granted access. If you're not currently part of a namespace or a group, as with all cluster services, you have to gain access, whether you're a PI or a lab supervisor or a postdoc or different use cases, and you're the manager of a project essentially. You can request access through us, and we can create a namespace for you where you're an admin and you can create namespaces under it and so on. Or if you're a student, you can ask your PI to join NRP. It's a process that can be done in less than a minute. All they have to do is log in and ping us, and we'll be able to add them. They'll be able to have their own project. Once they're in, they can add you. They can add everybody who they want, and then they can delegate admin access to you. So if a PI promotes a student to a PI to a namespace admin role, the student can add more students and more users to the namespace as well. Of course, all of that is explained in last week's sessions, which will be posted and in the documentation. But once you gain access to JupyterHub, either west or east, you gain access to a GUI spawner. So you can see it here in the previous slide, actually. You can see here a hint of what it looks like, and we'll go through it together. But you see a GUI spawner for JupyterHub instances, where you can pick GPUs that the count of GPUs, the count of CPU cores, the memory you're using, and so on and so forth. And first thing when you visit, you see the sort of explanation of options. So when you start a Jupyter Hub instance, you can see that each user has 5 gigabytes of default persistent storage. So Jupyter Hub runs in Kubernetes, and in Kubernetes you run containers essentially, and those containers are of an ephemeral nature. So when your Jupyter Hub instance stops and you start a new one, what's left is whatever is in your persistent storage. And persistent storage is mounted to your home directory. So the default username in Jupyter Hub is Jovian. So /home/Jovian right here, this is your persistent volume. That is 5 gigabytes by default. Because if there's an influx of users and not everyone is a persistent Jupyter Hub user, if they're fairly too large, that could lead to complications. But essentially, the idea here is that they're 5 gigabytes, not max byte, but by default. If you wish to increase it, you can ping us on Matrix, and we can happily work with you on that. But the main thing to note here is that those 5 gigabytes, if you fill them up, you fill up your home persistent storage, and that affects Jupyter. And the Jupyter process in your container will be negatively affected, and odds are it won't start. And once you fill it up, you'll have issues starting again, which we can triage together by expanding the volume. But so your work is not interrupted. Please always make sure that you don't fill up your persistent storage to the brim. Of course, storage in Nautilus is provisioned from different storage pools. So we have actual storage servers that are spinning up storage to the rest of the cluster. And by default, your persistent storage is created in the West region, which is essentially the West Coast. So if you want to create it in a different region, you can coordinate with us. We'll be happy to assist you with moving it. But essentially, as you can see here in this sort of depiction, so nodes, and that's the Kubernetes term for server. So the node is the abstraction for a server. And you can think as we have worker or compute nodes. Those are, let's think of them as the nodes that you reserve and run your workflows on. Whether you're running CPU flows, GPU flows, whatever work you're doing on NRP. We have nodes that do your work and nodes that spin up storage. And those are actually different computers, different servers, different nodes that are spinning up storage. So that's why we have a region picker where you can actually select the region to land close to the region where your actual node and actual storage are geographically close together. And the other thing is when you start a Jupyter instance, so Jupyter Hub runs in Kubernetes. In Kubernetes, we have distributed nodes. We have more than 400 nodes. They're spanned across the United States and across continents as well. And you can see What starts your JupyterHub instance is the Kubernetes scheduler. So when you select your resources, the Kubernetes scheduler is what looks at nodes and resources that are available. And you can see here we're depicting here these are different nodes, so different servers. You can see some of them might not be eligible for your server to start on for different reasons, like not enough CPU or different kind of GPU than what you're requesting, or in the wrong region if you're selecting a region, or there might be multiples that are eligible and have the sufficient resources and circumstances for your instance to start. One of them will be selected by the scheduler, and that's where your instance will start. And that leads to a level of consideration when you're starting a JupyterHub instance. Because JupyterHub, technically you don't need to know Kubernetes to use it, but if you know what's going on, it's easier for you to understand what's going on. For example, if you don't select a GPU kind, you're not always landing on the same server. You might land on a different server that has a different kind of GPU, and then you'll notice different performance. So your Jupyter Hub instance, when it starts, it needs to start on a node that is, first of all, not reserved for special use cases like storage. The node is online, not going through any maintenance, and has all the right circumstances, has the resources that are not committed to other users and other pods at the moment, and is not tainted. And of course, there's the link nrp.ai /viz. /viz is where we keep all the visualization links that you can look at. /resources, you'll see a spreadsheet view of all the nodes, which are servers that NRP has in real time. So it'll show you real time how much CPU is available, how much memory is available, and you can go on from there. Because let's say hypothetically you start a Jupyter Hub instance that just for the sake of argument you request, let's say 3 TB of memory. Odds are your container is not going to start because so whatever you're requesting, you need to make sure it's available and you need to make sure it's within the constraints that are available. So for example, our top node has like there's 8 GPUs maximum per node. If you go in and request, let's say 16 GPUs, for example, and that's across Kubernetes, not just JupyterHub, your pod is not going to start. It's going to be pending, and then it's going to time out. In the case of JupyterHub, it's going to time out without starting. And of course, like we said, you see the pickers for the resources you're requesting, and you see an image picker. So Jupyter Hub, we offer Jupyter Hub images. First thing is that we offer the official Jupyter Hub images. So you could have different flavors, SciPy, R, Julia, TensorFlow, PyTorch, different images that are preloaded. So those are Docker images. When you pull them, you pull the container that is pre-baked with the tools that support whatever workflow, if it's one of these official Jupyter workflows. So these are pulled from the official Jupyter image container images. But we also have another stack of images that is offered by BData, which is a company that offers them as open source with a focus on data science as well. So we provide them in the flavors of images as well. And you can read more on BData and our documentation on what these Docker images have to provide. And most importantly, we also have our own NRP images. So we built our own in-house stack of images that are built by NRP for NRP. That means they are built to satisfy running on the National Research Platform. That's where they're tested. So they're built to match our compatibility with, for example, the CUDA versions that we run on our GPUs, the compatibility with our GPUs that we provision, and so on. And NRP's images incorporate what, let me call it, an intelligence spawner. What I mean by that is that when you, for example, start a PyTorch image and you're requesting a CPU, PyTorch is configured to use CPU. When you're requesting GPUs in the mix, it automatically pulls the GPU flavor of the image that is pre-configured to let PyTorch use GPU and has all the NVIDIA and CUDA tools that are that you can use with the GPU acceleration. And we provide different flavors. One thing to mention here is that we have multiple desktop GUI flavors. That's you start a Jupyter Hub instance and you have a desktop launcher. Like you click on it, it opens a tab that has a full-on desktop environment with either no VNC streaming or Sulky streaming. So Sulky's GStreamer offers full desktop environments with an WebRTC streaming client, which is Sulky's. I'm mentioning it here because It allows for GPU accelerated streaming for your desktop environment with audio enabled. And of course, GPU acceleration is also optional. You have the option for CPU acceleration. And the Salkey's GStreamer project. It's open source, it's community driven, and some of the very main contributors are part of NRP and work on NRP and are live on NRP with multiple projects. So the community that drives Sulkies and GStreamer forward is also part of the community that drives NRP forward, and uh, we offer it as an image flavor where you can select the Selkies desktop. You land in a normal JupyterHub instance that has, as you can see here, a launcher that you click on it and you open a browser tab. You have a full desktop environment. This has audio streaming. So I can virtually go to Firefox, open YouTube, and start a video, and I'll hear the audio streaming. And this has GPU acceleration, which uses a GPU if you're requesting it, and falls back to CPU if you're not requesting a GPU. Now, two other things to mention about JupyterHub before we get started is that JupyterHub implements culling, and culling is, you can think of it as auto-terminating for idle or not interacted with sessions. So one of the features of JupyterHub is that since you're using this environment where you don't have to deal with Kubernetes, you don't have to worry about lifecycle management. So when you leave your session up and running, and let's say you started your JupyterHub service, you don't have to explicitly go and stop it. You're grabbing lunch, you went to bed, whatever you're doing. You don't have to worry about it idling resources, which is a factor that you have to consider when you're running Kubernetes directly. But if you're running JupyterHub, it auto terminates it. But one main distinction here, it auto terminates it when you, as a user, you're not interacting with it. So you don't have JupyterHub up and interacting with it. If you're running processes on the actual container, that is not included in what is looked at as interacting. So if you run, let's say, a machine learning training workflow in the background and you close JupyterHub and leave, it is going to get auto terminated. And that's where you get the Kubernetes. That's where you can do the more interesting stuff. You can customize things however you want, and that's what we'll cover in the next session. The other thing here is that we have something called Jupyter AI, which is a Jupyter extension that allows you to use LLMs as coding assistants, as chatbots within Jupyter, and we have it provided with all the NRP images, so it's there by default. It uses NRP's LLMs, and it provides many features like cell debugging, where you can just click on a cell and ask the chatbot to look at the cell and fix it. It provides entire notebook generation, where you can just ask it, hey, can you create a Jupyter notebook that solves Sudoku, for example, in Python? And has a chatbot like normal chatbots that you can interact with LLMs in, and you can bring your own LLM provider. So you can use NRP's LLMs, which are free, by the way, for academics, and free and open. Like the access to NRP's LLMs is for academics, but they're of course free. There's no cost involved, as with everything with NRP. And you can bring your own LLM provider. So if you have API access to a different LLM, you can configure Jupyter AI to use that instead. Of course, this is what it looks like. So there's two distinct things here. You can use the side panel, which is a chatbot inside of Jupyter, and you can use what Jupyter calls magics, where you can inside cells call the LLM to do work for you. And of course, we'll go over this. Well, you'll be able to use this with much more cool stuff, much more tools and agentic coding tools on the session on September 23rd, which is agentic tools and coding with the LLMs. And all right, we'll pause here on the slides and go to test it out ourselves. I'm gonna switch over to Chrome. First thing I want to verify here, can everybody see my browser window? All right, I see. Sorry, I lost the hands. Let me. Oh, hi, Mickey. Hi, Kurt.
Yep, no problem.
All right, awesome, awesome. Thank you very much. All right, so let's get started. I'm just gonna pause here for a few minutes while I just make sure everyone is on JupyterHub and that everyone can have access. Sorry, everyone. I'll just get to Q&A. Sorry for the interruption. Just making sure everybody's on, and I'll get to answer things as well. Okay. In the meantime, can everybody please try to visit jupyterhub-west.nrp-knowledge.io, and when you visit it, you're not logged in. This is what your screen will look like. So sign in with Authentic. Authentic is our authentication platform. Once you click on sign in with Authentic, you'll be taken to CI logon, and then you can log in. If anybody cannot access this window and gets shot down on not having a namespace or a group, please let me know if you haven't done so already in the Q&A, and I'm working on adding everybody. Right, if you asked for access and haven't provided an email, can you please send it in Q&A to make sure I can have it? For someone is asking about sessions being recorded, the sessions are recorded. Recordings will be posted on the training webpage. And is the password same as Element? No, it is not. For joining Matrix, you can use password authentication to join our Matrix server and the Element client, but for all cluster services that use Authentic, including JupyterHub, Coder, Kubernetes, you have to use CI logon. If you go through password, you'll not be able to log in because there's no password setup. You have to use their campus single sign-on. And link to training web page is nrp.ai/training. As if once you visit nrp.ai, which is NRP's website, let me show you here. You'll see here there's a widget that says ready to learn more about NRP. For more info, click here. This is the training webpage, which is nrp.ai/training. You can see here's the schedule, the Zoom links for each one, and as soon as you join in, you'll be able to as soon as you click join session, you'll be able to join the Zoom link. And as soon as we have the recordings, we'll be able to post them there. All right, so Jupyter Hub dash West. I see a question from Annie about not being able to access Jupyter Hub West. Is that still going on? I see Sam also raised her hand. You can unmute if you would like to. All right, sorry everyone, just making sure everybody can access. For image, you can select whatever image fits your workflow. I like to test things with a PyTorch image because it's one of NRP's built images, so it has all the tools I normally need whenever I'm trying to launch something. Desktop GUI is also a cool one to try out if you want to test out the desktop environment. All right. I see from Ramazan, you're not, I don't, can you please send in your email and make sure you're logged into nrp.ai? Your account is not showing up for me. Nabil, I just added you to the namespace. You should be able to follow in now. And Kurt, you can select whatever image you would like to try out. GUI desktop is a good choice with the desktop if you want to try it out. So for Shunfei, you can log in. So when it says interface can only be accessed by internal users, that means it's leading you to authentic. Can you please that means CI logon is your account. So and for authentic you're logged in, but can you go back to Jupyter Hub West and visit Jupyter Hub West again and try to log in? It should let you in this time. And please let me know if it doesn't. We can look at it together. All right, so someone's asking, I already logged into Jupyter Notebook. How to get back to Jupyter homepage? We'll show you that live in a second. Uh, Sam, you got denied because you need to be part of a namespace. I added you to a temporary namespace. You should be able to access now. And Annie, I added you to a namespace. You should be able to uh, to also log into Jupyter Hub. Kurt, are these container images publicly available in the registry? Yes, they do run on Jupyter on NRP's GitLab. That's where they're built. That's where the Docker files are. They're all completely open source. By that I mean our images that we host, the NRP images. And you can take them, fork them, and build on them. So let's say our images suit your use case, but you want, let's say, to install one extra package that you constantly use. You can fork our repos or copy our Docker files, add the one library or one line, build the new images, whether on NRP's GitLab or wherever you use it, and publish it to a registry, which our GitLab instance does support registries, or you can host it on a public registry and pull it onto your containers and your Jupyter Hub instance. Or your whatever wherever you're running Kubernetes, so direct pods as well. All right, awesome. So for iRog, when you want to add a user to a namespace, first thing to make sure is that they have logged into nrp.ai, because the dropdown to add users when you're a namespace admin is that the dropdown is from the list of current users that have logged in. So they need to log in to be shown as an NRP user that you can add to a namespace. All right. Sorry, everyone, almost done. All right, you're most welcome. All right, by now everybody should have access. Please let me know if you don't have access. I'm just going to answer a couple of questions. Is Jupyter AI better than Cursor or GitHub Copilot? That is more of a preference thing. I don't want to be on record saying this is better than this or that is better than that, but there is a distinction here. So Jupyter AI, it interacts with Jupyter more natively, and it's built for Jupyter where you can for example like you can point to a cell and ask it to fix this cell or that cell. It doesn't use agentic tool calling in which like it doesn't have the reiterative process like Cursor and Copilot, for example, do when you're ask them to do coding tasks. Just when it's more prompt based. And Benjamin, if large classes are interested in using this from 1 to 200 students, is this an acceptable number for using the services at a given time? So for the spawner, there's so typically to optimize performance, there are considerations to add in mind. First of all, for classrooms, ideally you would host your own instance, which we'll get to in a second, and we can optimize that to land on a specific set of nodes, for example, and pre-pull images and uh, have the correct configuration to have it start faster. We've had classes with hundreds of users. As long as you're asking us and coordinating with us, we can always guide you in deploying your own JupyterHub instance, so you can in deploying your own JupyterHub instance, so you can customize it. You can make sure it scales up and doesn't cause issues in classrooms, for example. And we're always more than happy to help in configuring. In namespaces, customized JupyterHub instances. Sulkys does need additional authentication. You can see it here in the spawner page. So the user is Ubuntu. The password is my password. So my pass WD. That is, of course, for you. And that's because it's exposed does not mean the users get access to it. It's still for each user. So users can't access yours, for example. And yeah. Uh, so, Junfei, we'll work through your authentication together. Let me just see. I'll see. Maybe we'll let me just show everybody through Jupyter Hub first, and then if we have time in the end, we'll. So I added you to this namespace. Can you try now? If it should go through, and of course we can try it together. Please let me know if it doesn't. And just to show you, so just as Jupyter Hub after you log in, let me log out again, log in. And you can see not going to select a region or let me select, for example, 2 cores, 9 RAM, 9 GB of RAM, just for the sake of it, the PyTorch image or the desktop GUI image, for example, started on an AMD64 node. You can see here, these are the Kubernetes logs. So for those of you who are familiar with Kubernetes, you can see successfully assigned to, this is the namespace name. This is my pod name inside of Jupyter, and this is attaching the PVC, which is short for the persistent volume claim for my persistent storage. And you can see, I see a question from Annie while this starts. Does the documentation go into detail into different Jupyter Hub images offerings? Yes, we can see. So this is the documentation just to show you live. And so in the sections about Jupyter Hub, you can see Jupyter, for example, here you can see that available images are described in the scientific images section. Here you can see the 3 stacks of images, which are the official Jupyter Hub images in the Docker stack, the bdata ones, and R ones with the links on GitLab and the description of them all. All right, Junfei, let me just look at your account while my instance starts. Okay, I'm just gonna wait a little bit for my instance to start. This might be slower than usual because we're all trying it right now. Can you please? Oh, sorry. Here's your email. Right, you can see it's starting to pull the image. So you can see the registry it's pulling from. It's GitLab dash registry.nrp-nautilus.io. If you have images on Docker Hub or on any public or private registry, you can pull images from them, and you can still authenticate in a secure way if you have private images that you want to pull onto your pod in general, Kubernetes. Okay, we're just gonna wait on it to start a little bit. And while it starts, let me just briefly go over deploying your own Jupyter Hub. So when you deploy your own Jupyter Hub, just to give you a brief overview, you have admin control over instances that start. So let's say you're a professor, you're starting a class on Jupyter Hub. You have admin control over the user's instances. So if you ask them to do work in their instance, you can still access it for grading and so on. You have access to customizing the interface, whether it's branding, whether it's different pickers. So I've seen one popular option is that for classrooms, for example, users prefer default configuration. So let's say a picker that has, let's say, 4 CPU cores, 8 GB of memory, another one that has 16 CPU cores, 32 GB of memory, for example, and then they're preset. It's not a picker for everything. So whatever options there are, resources, whatever is configurable in Kubernetes, you can customize the GUI spawner to sort of fit your use case. And that includes, for example, using FPGAs. For example, if the NRP Nautilus provides multiple FPGAs, which are provisionable through Kubernetes. You can add them as pickers. For example, if you use FPGAs in your namespace in your Jupyter instance, you can also customize the logic. So we default 5 GB as the default persistent volume claim size in our Jupyter instance, but that is the default we set for the ones we manage. If you spin up your own, you can customize it. If let's say you're spinning up Jupyter Hub for multiple users, but you want each user to start to have access to a shared data set, then you can create a shared volume that mounts directly to each Jupyter Hub instance at a specific mount path for every user. You can, for example, hard code the region it starts in. You can customize access to who has access or what institutes have access or explicit users, who the admins are, that sort of thing. You can run it at your own domain if you own a domain name. So whatever your domain name is, or XYZ or whatever .nrp-nautilus.io, and you can customize what images it uses. Uh, Whether users have pickers, you can bring your own images or use ours or whatever you're using, or you can hard code it also to bring up different specific images. Of course, we'll go over that and we'll go over deploying your own Jupyter Hub instances in a dedicated future session, and we'll go over using GitLab to build Docker images that could be used by Jupyter Hub or any Kubernetes pod in future sessions as well. First, before we talk about Coder a little bit, let me just check on our instance. Looks like it started. Just to give you a very brief overview, you can see I started the GUI desktop one. You can see here I have the desktop launcher. It starts no VNC. I can see my desktop environment once it loads. Let's give it a little bit of time while it loads, because here we go. So you can see this desktop right here. This is running in a Kubernetes pod that is my essentially my Jupyter Hub instance. So Jovian is the Jupyter names username. You can see these are my local directories. So if I list files here, you'll see I see the same files. And of course, I can access a terminal. This is not in my local computer or running on my browser on my local computer. It's running in the Kubernetes pod, so it's using the resources I request, and I can create Jupyter notebooks. I can add files, drag and drop, for example, and so on and so forth. And once I want to stop it, if I want to stop it intentionally and I want to look at different, if I want to go back to the hub's home, One link to know is /hub/home. This is where you can see the hub home link, where you can see my server or stop the server. My server takes you back to it. Stop my server stops it. You can see here, start my server. Once I hit start my server, your server is stopping. Let's wait on it a little bit. Server not running, launch server. I can see the options again. Of course, like I said, if you leave it idle and come back, you'll see this again because it auto terminated. And if you want to stop it intentionally, /spawn is where the spawner lives. /home is where you have the home options. If it's not running, it's start. If it's running, you can see the stop option and so on. If you're an admin of your own one, you can see an admin link, which shows you all the users. You can access their instances, see their info, and so on. And can we get our own subdomain in the nrp-knowledge.io domain? Yes, you can. You can run service deployments on it as well. You have that, so .nrp-knowledge.io, or bring your own domain namespace. And Shinfei will work through the issues together. If you let me just go over Coder very briefly, just to show you another way of accessing the cluster. Sorry, here we go. So this is the training page. Here we go. Sorry. So Coder, just to give you a very brief couple of minute overview. So Coder is another interface, another service that we have that also has a very similar graphical user interface where similar to JupyterHub's images and flavors, you have what Coder calls templates. And you can see that we have many templates for different use cases. One use case we use Coder a lot for is how easy it makes provisioning FPGAs, which are customized acceleration hardware to put in an oversimplified fashion that needs a lot of hardware configuration in your container to run correctly, needs massive development environments that are hundreds of gigabytes. So instead of each user having to install those and configuring the licensing for those and requesting the right hardware resources for those and so on, we have one FPGA template on Coder that does all of that in the background. So we install the tools, it mounts the shared volume with the tools, points the container directly to the license server, does all of that in the background. And that's sort of the use case that you can create with Coder if you deploy Coder in your own namespace. If you use Coder as a user, you get a lot of very handy and very cool features, including once you start your Coder instance, you'll see a window like this. You have a terminal button that you just click it, and you have a terminal in your browser window. You have no VNC desktops, Sulky's desktops, very similar to Jupyter. The cool feature and one of the main uses the users use Coder over Jupyter is that it has VS Code desktop. So it's one click of a button when you start a new workspace, and it connects to your local VS Code, the one that you configured to fit how you want on your local computer. Because a lot of users use VS Code as their IDE of choice, and Coder allows you to connect to your workspace directly from your VS Code. So whatever work you're doing on the remote container, on the remote pod, on NRP, but you still get to use your extensions and your customizations and so on. Coder itself as a tool, it's not a tool that we developed, it's a platform that we deploy. It has a command line interface that allows you to SSH into your workspaces and pods and so on. And the cooler thing is that Coder on the background runs Terraform, not Kubernetes YAML, which allows you to do much more cooler stuff. So one of the stuff we did is we deployed templates that fit the use cases of our users, including FPGAs, sulkies, so on. We configured those templates to use pickers that fit our use cases, and once they start, they have buttons that fit our use cases. So a terminal button, and VS Code button, and different IDEs, JetBrains, for example, and Zed and Cursor, they all have connectors through Coder. How we configure those is through Terraform. So whatever has a Terraform, what is called provider or module, is something you can add to Coder. So there are many cool ones. Let me go back to this slide, for example. So you can see here examples that we don't have implemented, but if you deploy Coder in your own namespace, you can add. One of them is called Slack Me, which is just a feature that DMs you on Slack once your workspace is done running the workflow it's designed to run. And of course, Coder, for us, it runs the exact same way as JupyterHub does. So it starts a pod for you. It starts a persistent volume claim of 5 gigabytes by default for you at your home directory, just like how Jupyter does, so we can have consistency. But when you deploy Coder in your own namespace, you can customize logic. So what Coder actually runs is what you configure it to run. So it could be a pod that is connected to a specific IDE that you use, or it could be a deployment or a batch job or whatever Kubernetes workflow that you normally run with YAML. You can configure Coder to do it with Terraform instead, and you can configure all the workflows. So essentially, whatever you do in Kubernetes, you can also do in Coder, and you can create templates that are extend beyond what Kubernetes is. So for example, technically there's, for example, public provider Coder templates in Terraform that you can use Coder just as an interface to launch instances on public providers as well. I know we're running out of time, but just to briefly show you the interface. Let me bring back my browser window again. So this is Coder. Sign in with Authentic as well. Same thing. If you can access JupyterHub, you can access Coder. You can see workspaces are the workspaces that I started, as in the pods or instances, or whatever you want to call them. Templates is where we keep our templates. Let's say I use the universal image, which is an image from Microsoft that has multiple development tools already pre-baked into it. I can name it my workspace. Select CPU and memory, for example, and start it up. And this starts my instance. Hope that gave you a little bit of overview of what JupyterHub and Coder provide. In the next session, we'll be going over Kubernetes and doing things manually, which using Kubernetes gives you more autonomy. It allows you to do more interesting stuff. Same things we do in Jupyter and Coder, and how we provision storage and how we request CPU, memory, GPU, all of that. You can do it in explicit definition in YAML in the next session. I'm just going to stop the recording here. So I stopped sharing and now we're Zoom.